Hello, Matthews Gatos here. In this video, we're going to look at how to apply the product rule. Let's get started. So what is the product rule? Well, it's a way of taking the derivative of a product. So to take the derivative of the product, I do derivative of the first function times the second function plus the first function multiplied by the derivative of the second function. So that is the formal calculus definition of product rule. If you want to see a proof of the product rule, I've done a video for that. The link is in the description. So that's the calculus definition. I have my own special way of doing it. Here is how I do the derivative of product rule. I do 1d2 plus 2d1, and you have to say the second part. Calculus is so much fun. So what that means is first function times derivative of the second plus second function times derivative of the first. So before we get into product law, let's actually do this by distributing and using power law. We know how to use power law, so let's actually do that to see if this actually works. So first of all, I'm going to write this as x to the 1/2 multiplied by 2 minus 3x. So distribute it inside the brackets, and I get 2 times x to the 1/2 minus 3 times x to the 1/2 plus 1 is 3/2. Okay, so there's my function. Let's now do the derivative. So that 1/2 comes down. 1/2 times 2 is 1. Decrease your power by 1. Minus that 3/2 comes down. 3/2 times 3. Decrease your power by 1. Okay, so now I'm going to factor. When I factor, I want to take out x to the smallest exponent, which would be -1/2, but I want to get rid of that fraction. I don't want a fraction inside, so I'm actually going to factor out a 1/2 x to the -1/2. So imaginary 1 in front, 1 divided by 1/2 is 2. X to the -1/2 divided by x to the -1/2 is 1, minus 9/2 divided by 1/2 is 9. X to the 1/2 divided by x to the -1/2, you keep the base the same and subtract your exponents. So what that means is 1/2, so the 2 goes on the bottom, x to the -1/2 is square root of x, and then I typically like to leave my leading coefficient negative, so I'm going to factor out a negative, so I can have -9x divided by -1 is 9x, 2 divided by -1 is -2. So that would be my first derivatives, looking at distributing and using the power rule. So let's copy that over to the next page, and we're going to do that using product law, and we should get the exact same answer. So I'll just paste that down there, see if we get the same answer. So same question, we're just now going to use product law. So my first function is x to the 1/2. The derivative of that, bring the half down, decrease your power by 1. My second function, the second part of the product, is 2 minus 3x, and then the derivative of that is just -3. So using my little rhyme, I know that the derivative is 1 d2 plus 2 d1. Of course, calculus is so much fun. And now we can just go ahead and factor. So let me just rearrange this here so that my number is in front. And then plus 1/2 x to the -1/2, like that. Just make it look a little neater. Okay, so looking at this, after you've done the product rule, your choice is to expand and group like terms or to factor a GCF. So I'm going to factor a GCF. So first thing I notice is I have a fraction. I don't want a fraction left, so I'll take out that 1/2. X to the 1/2, x to the -1/2, I take out the smaller exponent. So -3 divided by 1/2 is -6. X to the 1/2 divided by x to the -1/2, keep the base the same, subtract the exponents. Plus, over here, 1/2 divided by 1/2 is gone. X to the -1/2 divided by x to the -1/2 also gone. So plus 2 minus 3x. So on the bottom here, the 1/2 is divided by 2. X to the -1/2 comes down. And then I have -6x and -3x is -9x plus 2. Oh, that looks familiar. I was just at that point on the last question. All I'm going to do is factor out my negative so that I can have a positive leading coefficient. And you can see that voila, they match. And in my opinion, the product rule was a little bit easier. So now that we know product law works, let's try some other examples. Okay, so in this one here, I have a y equals equation and I want the derivative. Little note here, typically if you start with y, end with y prime. So here is my first function, here is my second function. So 1 is 2x cubed plus 5. D1 is, bring the 3 down, 3 times 2, decrease your power by 1. So my second function, the second product would be 3x squared minus x. D2 would be, bring the 2 down, 2 times 3 is 6. X, decrease your power by 1, minus the derivative of x is 1. So to do my derivative, I do 1 d2 plus 2 d1. Of course, calculus is so much fun. And now I'm ready to go. So again, once I've done the product law, my choice is distribute in group-like terms or factor a greatest common factor. So I don't see a greatest common factor, so I'm going to actually expand in group-like terms. So 2x cubed times 6x, 2x cubed times negative 1, 5 times 6x, 5 times negative 1, and then distribute the 6x squared. So 6x squared times 3x squared, and 6x squared times negative x. So altogether, I have 12 and 18 is 30x exponent 4. Negative 2x cubed and negative 6x cubed is negative 8x cubed. And then I'm going to have, oh, I'm missing my x here. I have a 30x. So plus 30x and then minus 5. Altogether, that would be your first derivative. Okay, let's try another one. So this one here, I have my first product and my second part of the product. So again, I'm going to do the first derivative. I'm starting with f of x, so I'm going to end with f prime of x. So my first term is 6x. The derivative of my first is 6. My second term is 3x plus 1 all cubed. The derivative of that, 3 comes down. Decrease your power by 1. And don't forget you have chain rule. On the inside, the derivative of 3x plus 1 is 3. So really what this is 3 times 3 is 9. And 3x plus 1 squared. So here's the derivative of the product. 1 d2 plus 2 d1. Don't forget, calculus is so much fun. Isn't it fun? Okay, now, again, we have a choice of expanding grouping like terms or factoring a GCF. I definitely see that there is a GCF. So looking at my first term and my second term, I can see I have a GCF of 6 that I can take out. And I have a GCF of 3x plus 1 to the smaller exponent is 2. So I have 6x divided by x is just x. I have the 9. And then I have 3x plus 1 squared divided by 3x plus 1 squared is actually 1. So I'm okay with that. Plus 6 divided by 6 is gone. 3x plus 1 cubed divided by squared. 3 take away 2 is 1. So f prime of x is equal to 6, 3x plus 1 all squared, times 9x plus 3x is 12x plus 1. So that would be my derivative. Okay, let's start with the root. So again, I have product, 2 different functions. My first function is x squared. The derivative of that is 2x. My second function is x cubed plus 1. I'm going to write it as a power to the 1/2. So the derivative of the second, bring the half down, decrease your power by 1, and don't forget derivative of the inside, 3x squared. Okay, so let's do the derivative. So f prime of x is 1 d2 plus 2, and then D1 because calculus is so much fun. So again, we can expand and group like terms or factor a GCF. So I have two terms here, and I can see I am going to factor a GCF. So a couple things going on here. So first of all, I see in both of my terms, I have a GCF of x. I want to get this fraction out, so I'm going to factor out a half. And then I have x cubed plus 1 to the smallest exponent, which is negative a half. So let's factor that out. Okay, so first of all, half divided by half is gone. X cubed plus 1 to the negative a half divided by that is gone. So, and then I have x squared divided by x is x multiplied by the remaining 3x squared. In the next one, I have 2x divided by a half x. Well, the x's cancel, and 2 divided by a half is 4. X cubed plus 1 to the 1/2 divided by to the negative half. You keep the base the same and subtract. Half, take away negative a half is 1. Okay, so let's tidy this up. So in the denominator, from the outside, I have divide by 2 because it's a half. And then this negative exponent comes down. What stays in the numerator is the x, and then let's tidy up what's on the inside here. So x times 3x squared is 3x cubed plus 4x cubed plus 4. So all together, just finishing on the top here, I have x times 3x cubed and 4x cubed is 7x cubed plus 4 all over 2 root x cubed plus 1. So that would be your final derivative. Okay, our last question here, I just wanted to do an application question with you. I want to find the slope of the tangent line to f of x at this specific point. Now remember, slope of the tangent line is the derivative of the function. So slope of the tangent line is equal to the first derivative, but I'm going to do this at the specific point x equal to 1. So my function here is a product. Let's list out the first term. So the first term is 3x squared plus 2. The derivative of that is 6x. The second term, 2x cubed minus 1. The derivative of that would be 6x squared. So let's go ahead and apply the product law. So to find the first derivative, I'm going to do 1 d2 plus 2 d1. Calculus is so much fun. And normally I would just expand group like terms or factor, but because I want to know the slope, here's my little tip for you. If you want to know the slope, you just want a number value. So after you take the first derivative, just substitute your value for x. You don't need to simplify. There's actually a greater chance of you making a mistake if you simplify. So we know that x is equal to 1. So I want to find the first derivative when x is 1. So 3 times x squared plus 2 multiplied by 6 times x squared plus 2 times x cubed minus 1 multiplied by 6 times my x value. So what I'm going to do is actually plug my x value in inside the bracket. So it's a value of 1. So I just plug in 1 here. And then it's just a number crunching question. So f prime at 1 is 1 squared is 1 times 3 is 3 plus 2 is 5. 1 squared, 1 times 6. 1 cubed is 1 times 2, so we have 2, take away 1. And 6 times 1 is 6. So 5 times 6 plus 1 times 6. That means that my first derivative when x is 1 is 36, which makes the slope itself 36. So that is how to do derivative of a product. So maybe if you're looking for some math ideas for your favorite math teacher, you could get this beautiful shirt. Calculus drives me mad. I like it. So I hope this video helped. If it did, please give it a thumbs up and hit subscribe so I can help more mathies just like you. Thanks for watching, and I'll see you for the next one.